Part 3, mole conversions. Mass to particles. Remember, particles represent an atom, a molecule, a formula unit, or particles to mass. Need a periodic table, something to take some notes, calculator, something to write with. So don't forget, these are our conversion units. We have these units of conversion, which we've used in the past. We have this. Now we're going to use both. We're going to use both sets. Okay, so let me walk you through that. So it says how many grams are in this many atoms. So we're going to start, like always, with how much we're given. We're going to start with the number that we have and the unit and the chemical formula. Okay, so we're going to start with 7.14 times 10 to the 26 atoms of iodine. Now, iodine is diatomic, so it would be I2. Okay, we know that whatever unit we have here, we have to have the same unit here. So this is going to be atoms of iodine right here. And then we have to go back and think about our conversion factor. What goes with the word atoms? The 602 to the 23rd number. So then we're going to put here 6.022 times 10 to the 23rd atoms of iodine. We know if we look back at our conversion factor that atoms of iodine is equal to 1 mole of iodine. So then we will put 1 mole of I2. So atoms of iodine cancel, but I want grams. So because the only thing I have left right now is moles, I know I'm not done. The unit I have left is moles, so I'm not done. Pardon me. So I need another grid. I know that I have to follow that pattern of having, that would be moles, same unit and chemical formula. So I have moles of iodine here. I've got to have moles of iodine there. I need to get to grams. I know for every 1 mole of iodine, there are 253.80 grams of iodine. Remember, that's the periodic table number, the molar mass. I calculated that ahead of time here to make sure that that was done a little quicker. So moles of iodine cancel with moles of iodine. So start with 7.14 times 10 to the 26 atoms of iodine. I use the fact that I know there are 6.022 times 10 to the 23rd atoms of iodine for every 1 mole of iodine. Okay, remember that this is a conversion factor that we know atoms to 1, 602 to 23rd to 1 mole. Then I need to have the same unit and chemical formula on the bottom of the next box so that things canceled. I know 1 mole in my conversion factor. 1 mole equals X grams. My X is my periodic table number or my molar mass. I figured out what that was. Excuse me. Now I'm going to multiply across the top, multiply across the bottom, and divide the two. So on my calculator, I'm going to take 7.14. Remember, you need to use the EE button or the times 10 button. You should not be using your caret key. So 7.14 EE to the 26th times 253.8, hit equals, divide by 6.022 EE to the 23rd, and I get on my calculator in scientific 3.00918 blah 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 times 10 to the 5th grams of iodine. Okay, now we got to do sig figs. This has 3 sig figs, this has 4 sig figs, this has 5 sig figs, so I can only have 3. So 3.01 times 10 to the 5th grams of iodine would be my final answer showing sig figs. I suggest that you work through this on your calculator to make sure you can get my same answer, including the value of the exponent. Okay, next example. Example 8, just like before, we're going to start with what we're given, 32.18 grams of vanadium chloride. This is a +5 and a -1, so it'd be VaCl5. Okay. I know that I have to have grams of vanadium 5 chloride here for it to cancel. I know that in my conversion factor, X grams equals 1 mole. So then I know 1 mole of vanadium 5 chloride goes on top. I got to get the value of the X grams. The molar mass, if I do 1 vanadium and 5 chlorines, is, try that again. There we go. Okay, 228.19. Remember that for molar masses, we're always going to ignore sig figs, and when we calculate a molar mass, we're just going to be consistent with each other and always round to the second place past the decimal. So grams of vanadium chloride cancel, leaving me moles of vanadium chloride. I can do this, vanadium chloride. But I want formula units, so I'm not done because I have moles, so I got to do another grid. I know whatever unit and chemical formula I have here, I must have in the bottom of the next box so that they will cancel. And I know for my conversion factor, 1 mole of vanadium chloride, vanadium 5 chloride, would equal 6.022 times 10 to the 23rd formula units of vanadium 5 chloride. Because I know for my conversion factor, 1 mole of anything equals this many formula units, or atoms, or molecules, or particles. Remember that 602 to the 23rd will never be with the word mole, and 6.022 times 10 to the 23rd will never have the unit of grams after it. Again, 6.022 times 10 to the 23rd will never have the unit of mole after it, and 6.022 times 10 to the 23rd will never have the unit of grams immediately after it. So moles of vanadium 5 chloride cancel, leaving me this value here. So we're going to then do the math. We're going to multiply across the top, 32.18 times 6.022 EE to the 23rd, hit equals, divide by 228.19, and I get an answer of 8.49239 times 10 to the 22nd. Let's look at sig figs. I have 4 here, I have 5 here, I have 4 here, so I can have 4. 8.492 times 10 to the 22nd formula units of vanadium chloride. Okay, again, I would use your calculator, make sure you can get my answer so that you know you're putting things into your calculator correctly. I will check that answer here while you are checking yours. Okay, got that answer twice. I'd like you to pick whichever candy bar is your favorite and try this one. Pause the video and then advance the video or start the video again and check your answer. If you didn't get it right, as always, go back and try another one. If you can't figure out why you've got it wrong, please check in with me. Remember, one thing that I've noticed where my students get these wrong is you've miscalculated the molar mass. So before you know it's wrong and assume it's wrong, double check your molar mass. Make sure you're getting the correct molar mass before you get too worried. Okay, based on your favorite character here of the listings, please pick one and try one of these problems. Pause the video and then start the video again to check your answer. Did you get it right? If not, go back and try another one. Again, if you cannot figure out what you've done wrong, please reach out. We can have a conference. I can try to do it over email, but I definitely am here to help you. Okay, so the last part of this video is just going to combine them all together. Okay, so it is going to combine them all together, meaning that we can do any of the 3 kinds of problems. So just to practice that, I've got made up 3 additional problems for us to go over, not in any particular order. Keeping in mind we have these conversion factors and this one, so we really have 2 conversion factors we're dealing with. Let's start with this problem. And I put the 2 that we would use down here. We may or may not need both of them. We'll just have to see. So as always, you're going to start with what you're given. So 36.15 grams of calcium sulfide. Now, I don't even need to necessarily worry about where I'm going yet, but I want to at least think about the fact that I know that calcium sulfide has to go over here, and specifically grams, so that it cancels, right? And I know for my conversion factor that if I have grams, the opposite box must be 1 mole. 1 mole of the chemical formula. Okay, and I've calculated the molar mass to be 72.15, so grams of calcium sulfide cancel, leaving me moles. That's what I needed. I know I'm done, so I can go ahead and calculate my value here. So let's do 36.15 divide by 72, because it's down, 72.15. Multiply across the top, multiply across the bottom, and divide, or think about when it's down, you hit equals and then divide by it. 0.5010, because I can only have 4 sig figs, moles of calcium sulfide. Let me check that answer and make sure that answer is correct. So let's try another example, just kind of mixed up here. Okay, example 10. Again, we're going to start with what we're given. We're given 6.224 times 10 to the 32nd formula units of barium phosphide, I know that I have to, for units to cancel, have formula units of barium phosphide here. And I know that with the unit of formula units, I have the number 602 to the 23rd. So 6.022 times 10 to the 23rd will go here. And I know that if I have 6022 to the 23rd, the opposite box must be 1 mole of the same chemical, because both of these, all of these conversion factors must be followed by the same chemical. Okay, so formula units of barium phosphide cancel, and I have left moles, but I need grams, so I'm not done. That's why I started to make a grid. So I got to keep going. So I have moles, got to have moles of barium phosphide here. And I know that I want to get to grams, so this conversion factor will help me. I know 1 mole of barium phosphide is equal to its molar mass. I calculated that previous to starting these notes, 473.93 grams of barium phosphide. Again, I use the periodic table number. So moles of barium phosphide cancel, leaving me grams, which is what I wanted right there. So now I'm going to multiply and divide and get my answer. So you're going to take 6.224 to the 32nd, divide by 6.022 to the 23rd, times 473.93. And I get on my calculator 4, let's see, I can have 5 sig figs, 4 sig figs, 4. So 4 sig figs, 898 times 10 to the 11th grams of barium phosphide. Well, let's make sure that answer is right. Again, let's do that number math again. So 6.224 to the 32nd, EE to the 32nd times 473.93, hit equals, divide by 6.022 to the 23rd, hit equals again, 4.89827, blah, 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 but 4.898 times 10 to the 11th grams of barium phosphide. Again, use your calculator and make sure you're able to physically get the answers on your own calculator. If you're struggling with any of this, please reach out for a video conference or a email. We can email back and forth. All right, number 11, last example before we finish up with this skill. So we're going to start with 7.039 times 10 to the 29th atoms of nitrogen. So we're going to start with what we're given. We know we have to have atoms of nitrogen here, and we know the number that goes with the word atoms has to be there of nitrogen, so it cancels, is 6.022 times 10 to the 23rd. What it's equal to goes on top, 1 mole of what? Of N2. So atoms of nitrogen cancel, leaving me moles. And I don't even need this grid because I'm 2 moles, so I'm going to go ahead and erase that. We don't need to continue. So we were already done. Once I saw my units, I could see I'm done. So now I'm going to multiply across the top, multiply across the bottom, and divide. 7.039 to the 29th times 1, divide by 6.022 to the 23rd. And I get on my calculator, thinking about 4 sig figs, 1.169 times 10 to the 6th moles of N2. Let me check that again. Again, 7.039 EE to the 29th. Divide by, because it's underneath, 6.022 to the 23rd. And I get 1.169 with rounding of sig figs times 10 to the 6 moles of N2. Remember, if you want to earn credit on this, you must show a number, a unit, and a formula. A number, a unit, and a formula. Number, unit, formula. Number, unit, formula. That is the expectation if you want to earn credit for doing these problems. So make sure that you're doing that. So what I've done is shown you all the 3 different methods of what we're going to do, and then a combined method of using them and knowing when to use which one. Please get some good practice in. You will have assessment over this very soon. Have a great evening. Miss y'all.